Hi, my name is Joey Maranka, and I'm going to be covering synovial joints today. So synovial joint, in case any of you are unfamiliar with it, it's also known as the diarthrosis, but it's the most common and most movable joint in the body of any kind of mammal. So these are your knees, elbows, hip, etc. They're very common in the body, as I will now go over. So to start with some common terminology for these synovial joints, the bone, obviously, is any relatively distinct portion of the skeleton. Now, articular cartilage goes around the joints, and what this does is it decreases friction and distributes loads on joints to prevent stress. So whenever your articular cartilage is damaged, you'll notice that there's more stress on it because this cartilage isn't preventing the stress anymore. So we went over this. The periosteum just covers the bones and it provides protection against the environment. And if you look right here, there's a little gap right in here, and this is filled with synovial fluid, but it's sealed off by the synovial membrane. And what this is it lubricates the joint so that it'll help it glide and it'll help it be more fluid rather than rigid, because rigidity is very bad in a joint. But the synovial membrane just seals this off, and the joint cavity is where the synovial fluid basically inhabits. So now, moving on with the actual joints, we have 5 basic main joints. We have the hinge joint, which is like your elbow or your knee, and it basically moves, flexes, and extends. For instance, like a door hinge. It can only go in and out, or flex and extend. The next kind is a gliding joint, and this would be actually found in your your carpals and your tarsals. And these allow the bones to glide past one another, either up, down, left, or right, or diagonally. So as you can see right here, the little peg can move this way, up, down, anywhere like this, along this plane. So that's what this can do. The pivot joint, many of you may have not known this, but it's a joint that only allows rotary movement. And for an example, this would be turning your head left or right. So as you can see, here's a little top, and you'd be spinning it left or right. So that's the only 2 ways it can move. Obviously, you can move it up and down and stuff, but that's part of a different joint that we really won't go over right now. And the next one would be a saddle joint. So a saddle joint basically is a joint that is concave on one side, which means it has a dip in it, and convex on the other side, which extends out of it. And this allows the joint to move back and forth in limited movements from side to side. So as you can see here would be the concave side and the convex side. And these arrows show the movement. And the real life example would be, here's your thumb and here's your fingers. This can move like this and limited side to side. Simple enough, right? So the last one we have is a ball and socket joint. So a ball and socket joint basically has one bone with a spherical end, which would be right here, and one bone that has more of a cupped shape, which would be right here. And basically this joint allows the joints to have rotary movement. So you could see here's a little ball, and here would be basically a bowl. So it can move around if you're moving like this, you can move it all around like this. So it provides one of the most movements of all these joints. So some of the terminology for some of these joints is the origin, which is basically the most proximal part of the bone, which has a greater mass and is more stable. Insertion would be the place of attachment, just like a muscle is attached to the bone. That would be the insertion. Now, for some of the trickier stuff, this stuff is a little harder to understand, but I'm just going to go over very briefly, just so that you guys have a basic understanding of it. So a first-class lever uses a fulcrum between the applied forces of the load. So as you can see here would be an example. So the load would be over here, or where the jaw is. The fulcrum would be right here where the neck is, or right here on the balance beam, and the applied force is down, so you would be moving your head backwards. A second class lever is, the fulcrum is at the end, which is right here, and the applied force is at the other end, and also the load's at the other end. So this is the most stressed one. So it would be moving your heel up. And the third class lever is just the fulcrum is at one end, the load's at the other end, but the difference is the applied force is in the middle. So this would be like your elbow flexing. The load basically is a weight or mass that's supported, and the applied force is the force that is being applied.